They knew they were different, and yet they interacted, they certainly bred, they had children, the children were raised. It must have been an incredible thing to have lived on a planet with different human species and to have encountered them. What must that have been like?
I'm Adam Hunt, and this is the Evolving Psychiatry podcast, rethinking mental health through an evolutionary lens. Share it with the people who matter, like it if you like it, subscribe if you want to hear more. Dr. Derek Tracy is the Medical Director of the West London NHS Trust and a Senior Lecturer at King's University College London. He has published more than 100 peer-reviewed scientific papers and 15 book chapters, including 2 in the upcoming Cambridge University Press volume on evolutionary psychiatry, which are excellent, and I'm really looking forward to hearing about. He has also received more awards and appeared on more news and television outlets than I have time to mention. His LinkedIn is very impressive. So thank you, Derek, for joining us today. It's going to be really fascinating to talk about your chapters. Thank you.
Pleasure.
So chapter 3, you call Hominin Evolution 1, the origins of Homo sapiens. So the story of humans is the story of many human species coexisting on the planet for millions of years. And it's not just this linear process leading to us, to Homo sapiens. Your chapter kind of talks about all of these different species. Could you talk a little bit about the diversity of humans on the planet?
Yeah, and I think this is a really common misperception. So we're all familiar with that famous image. It's often called the March Progress or the March of Progress. So we've seen it on T-shirts and posters where we get an ever more erect hominin species going from an ape-like one to standing up with a fully erect human. And it's a meme that's often joked about too. So there's an idea that evolution has led to us. And to turn that around, Richard Dawkins famously said that every living organism can trace in an unbroken line its ancestors all the way back to the last universal common ancestor, sometimes called Luca. So there's a seductive element of looking backwards through our history, which is unbroken all the way back, and therefore playing that forward and seeing evolution driving towards us. But that's a real misperception of what it means to be human. So the genus Homo, which we're one species within, we're Homo sapiens, is at least 2 million, 2.5 million years in existence. And during its time, there have been lots of human species, some of which were ancestral to us. What's fascinating to me is that it's the last 25, 30,000 years that we have been the sole human species. That's about 1% of the time that humans have existed. So for 99% of the time humans have existed, there have been more than one species. But that's not in our cultural memory. So we see it as a drive towards us. And I think if we think about any other animal species, we think about primates. We're very familiar and okay with the concept of being chimpanzees, gorillas, different animals that are related, living alongside each other, but being distinct too. And that's been the case for most of our history. So before Homo came the genus Australopithecus. People might be familiar with that. So Australopithecus afarensis is very famous one where Lucy, that famous skeleton, is the first definite biped. But there are multiple Australopithecines. Some of them were what were called robust. They just weren't ancestral to us. They looked a bit more like a gorilla in their face. Within genus Homo, we have Homo habilis going to Homo erectus. And interestingly, we might talk a little bit about this later on. There's a gap then of a few 100,000 years. We're not quite sure what happened. It's sometimes called the muddle in the middle Pleistocene. But by about 300,000 years ago, we have 3 major hominins, 3 major human species living side by side. There's Homo sapiens, and we're in Africa at this point. There's Homo neanderthal, which is in Europe, and Homo denisova, which is in Southeast Asia primarily, and in towards China. So 3 major hominin species living side by side, and there's really good evidence that when they met, they would interbreed, and this actually challenges the idea of are they different species, which is maybe a bit of a semantic argument to get into. So at least 3, and then we have some other really interesting human species living at the same time. There's been some fascinating finds in the last 15 years or so, particularly on Southeast Asian islands. People might be familiar with the story of Floresiensis, sometimes known as the hobbit species, that was found in Southeast Asia. And this animal was about 3 foot tall. I say animal, it's a human species, had a brain capacity of about 400 cubic centimeters, ours about 1,300, and yet had evidence for using tools. It was a small human. On a nearby island was another human species called Luzonensis. We've enough data, it looks about the same height, but we've enough data from the bones to know it's definitely different from Faresiensis. And another really interesting find was from southern Africa, a species called Homo naledi. And naledi is really interesting, and it's got this really strange mix of archaic, so it's quite a small-brained animal, and modern features. But below the neck, it's quite like a modern human, although its arms are longer and it seems better for climbing. So I always find an amazing idea. Maybe 100,000 years ago, 50,000 years ago, there's 6 human species. And in fact, the last of Homo erectus only went extinct about 100,000 years ago, and they clung on in Java. So they were living side by side, as happens with other animals. I often picture that in the original Star Wars movie, where they go into the bar and all different creatures are there. These different human species existed. And one of the thought experiments I sometimes have, I don't know if it's an experiment, maybe it's just a thing I like to imagine, is what do they think when they met each other? They knew they were different, and yet they interacted, they certainly bred, they had children, the children were raised. It must have been an incredible thing to have lived on a planet with different human species and to have encountered them. What must that have been like?
Right. Yeah, it's fascinating. So different, and it's a wonderful story that we are kind of revealing now, especially with ancient genetic data, and yeah, it's really amazing stuff. So in the chapter, you mentioned some key factors which could have led to the development of brain growth, which is obviously very special in humans and Neanderthals. So could you talk a bit about those factors possibly which drove this kind of cognitive and neurological expansion?
So if we go back to Australopithecus, going back 3-4 million years ago, Australopithecus, its brain, it was a biped, so it was walking on 2 feet, but its brain was about the same as a chimpanzee's. But by the end of the Australopithecines, by the time they go into genus Homo, it's getting a bit bigger, but it's still a relatively small-brained animal. The driver from the move from Australopithecus to genus Homo seems to have been environmental change in Africa about 2.5 million years ago. And a few things happened. One is the climate changed and warmed, became drier, and a lot of woodland within Africa moved into more savanna-like environments. And so that was a big challenge to organisms at the time. You've got to adapt and survive to that. And the other thing within the microclimate at the time, the evidence suggests that there was, not only did it become drier and potentially hotter, there was much more variability. So year by year, in terms of things like monsoon cycles, volcanism with volcanoes and so forth. So the picture is instability and a general shift towards savanna. This seems to have been an evolutionary driver for being adaptable and versatile. What you need here is to be a non-specific species. If you've only got one way to live, you're in more danger here than if you're quite an adaptable, nimble organism. And certainly with this, it's hard to prove that that's what causes the change. But around that time too, we see some significant changes in the physiology of genus Homo at that point. It's gone bipedal, but its feet are becoming better adapted to walk and to run in a different way. Australopithecus is not quite so adapted. And when we think about change of brain growth, one of the things we've got to remember is how calorie hungry your brain is. Your brain takes about a quarter of your metabolic input. It's about the same energy required for your brain as all the muscle in your body at rest. I mean, it's a lot of energy. So you need an animal that's going to be able to get more food than it needs if any mutations occur that are going to select for bigger brains. You've got to have an organism that can allow that to happen. So we've got an animal that's gone bipedal. And a few interesting things happen with that. When you go bipedal, you absorb less heat, less sunlight. So if you think about when you go sunbathing on a beach, you don't stand on the beach and stand upright, right? You never see anyone sunbathing like that. You lie down to expose greater surface area. Conversely, when you go upright, you get less direct sunlight. So these bipedal animals are overheating less. They can stay up for longer. The next thing that happens when you're bipedal is it's hard to master bipedalism. Very few animals have done it, but once you do it, it's a very energy efficient way to move. If you compare a chimpanzee to a human, it takes them about twice as many calories to cover the same distance because they're knuckle walking. It's not an efficient way. Not only that, we can go much further with our strides than knuckle walking. So now you have an animal that can be out for longer. It can roam much further. So you can see the advantages that are beginning to occur if you're now out on the savanna compared to animals that are not going bipedal. When you're going bipedal, your hands are suddenly free and they can begin to hold and carry things. And and these things are all interplaying. So
Mm.
it's not one thing happens and then something else is. At the same time, we're beginning. It starts with Australopithecus, but in genus Homo, we begin to get opposable thumbs. We're beginning to get better at holding and grabbing things. We're beginning to use tools, and this interplays with cognitive development, because although you need some physicality to hold the tools, there's lots of other things. If you're going to make a tool, you need to forward plan, you need to mentalize what that's going to look like. You need to understand the fracture dynamics of rocks. You need to be able to teach. Now, this introduces an interesting question that's unanswered. Do you need language, or can you
Mm.
observe and model? But there's really interesting experiments with college students. If you try to give them stones to tell them to make stone tools, they can't. And
Yeah.
we're really clever because you have to have seen it and been taught it. So that's beginning to happen. So you've got this animal that is roaming further, faster, using its hands, making tools. And then another thing comes along that begins to facilitate brain growth at this point: how we consume food. So Australopithecus was primarily what's called a frugivore. It ate fruit, a bit like chimpanzees today. Chimpanzees get about 2% of their energy from meat. They'll take it when they can get it, but they're primarily fruit eating. But meat is a really calorie rich food. If you can get it, it's a great source. And meat does two things: you get a lot of energy in it. The second thing is it doesn't take a lot of GI tract, gastrointestinal tract to absorb meat. So it allows you to shrink your gut. Now, that's really helpful. There's a hypothesis called the expensive tissue hypothesis. Your GI tract takes up so much energy. If you can shrink it, you can use your calories elsewhere. So a meat-eating animal is getting more energy than it needs, and it doesn't need that expensive gut, which it can begin to shrink. And then the big leap seems to occur when we start to cook food, or we eat cooked food. That was probably originally an opportunistic thing. There's evidence to suggest that maybe early hominins were following fires.
Mm.
And we think these days a fire is a very rare thing, but in a natural environment, fires occur all the time in wild landscapes. And to spot a fire was probably a very helpful thing. If you think about a wildfire, it's probably going to be a place where you're going to have wounded and dead animals. So it would be an obvious place to go to look for food.
Mm.
And by eating what were then cooked animals, cooked meat releases 40% more energy. It's a very,
Right.
very rich source. And the big leap seems to occur when this bipedal, wide ranging, freehand, tool holding animal starts to cook its food. I'm guessing it did it because it tasted much nicer when it was cooked. It wasn't doing it trying to get in extra calories. It wouldn't have understood that.
Right.
And now this animal, which we're thinking about Homo erectus at this point, absolutely has more energy input than it needs just to live. And what that means is any mutations towards bigger brains can be supported. But again, to go back, that this is not a single step. This is a process over millions of years. That's again, if we think about the tool making, that would be partly done in your parietal lobes. It's integrating lots of sensory information. So an animal that an adaptation that made it better at making tools is more likely to produce offspring. That those offspring have better developed brains that are likely to make better tools again. So you
Right.
can see this iterative process that's
Mm.
occurring at every level, from walking to running to hunting to using its hands. And this is where we get the brain growth.
Right. It's an amazing feedback process that obviously
Yeah.
pushed Homo sapiens to where we are today, where we've filled every ecological niche on Earth. But you do point out that there's this kind of like slight uncertainty as to why us. Why is it that Homo sapiens managed to survive and others didn't? So could you talk a little bit about that process, like what we do and don't know about? Yeah.
Yeah, and this is interesting. This is maybe another interesting point to another analogy with the march to progress and our common conceit. So the first conceit is that it all led to us, and the second is we are the most successful. We are the current inhabitants. So if we think about Neanderthals survived for at least 350,000, 400,000 years, that's longer than sapiens. So by objective measures, Neanderthal was a more successful species. And I don't think many people would take you up on a bet that we've got another 100,000 years to live as a species, the way the world's going now.
Mm.
Denisova, the other great hominin, lived for about 300,000 or 400,000 years as well. So it depends how one frames this. They're not alive now. So of course, there's a history is written by the victors, as I said. So are we more successful? We're here now, but we haven't been here for longer. Certainly, there was a long-standing assumption that we must have had a predominance, a superiority over the other great, I'm taking the three great hominins now, sapiens, Denisova, and Neanderthal. I'm going to ignore the island species and Naledi. It's hard to be certain. There certainly seems to be differences between us and Neanderthal. And as a side note, we've very little information about Denisova. Denisova seems to have been a much more successful species, genetically much more diversity than Neanderthal. We don't see as much. There's probably a scientific confounder that a lot of the science was done in Europe at the time. So there's probably more of a bias with that. There's going to be so many exciting finds about Denisova, I think, again, in the coming years. But if we take the primary comparator of sapiens and Neanderthal, it's debated, but there are some areas of cultural differences that it looks like sapiens might have had a superiority. So the question is, were we cognitively more adept? So if we think about stitching of material, it seems much more sophisticated in human shawls, whereas Neanderthal seemed to use more of a cape around them. We were stitching. We had blade tools, which are longer than they are wide, and that allows things such as making awls and stitching of material. Funeral goods seem more complex and intentional with sapiens than with Neanderthal. There is evidence that there seems to, and some of the abstract art, there has been art found that is Neanderthal, but it seems more symbolic and more complex with sapiens. So there's definitely an argument of potentially a more cognitively adaptive early hominin coming from Africa than Neanderthal was in Europe. That said, I think we have to have lots of circumspection with that. There's a great book by Becky Sykes on Neanderthal out recently that I really commend, and the gap is really narrowing. So the differences we thought between us and Neanderthal in the last 10 years have really, really come down. And some people argue it may be minimal. We don't know if Neanderthal had language, and they may well have done. But there's some argument for some differences. I think there's not an argument that we went to active war. We didn't come out of Africa, invade, and start fighting with them. I mean, that may have happened, but that's not an overwhelming argument. It definitely seems that even before sapiens got to Europe about 45,000 years ago with the main exodus into Europe, that Neanderthals are facing a genetic bottleneck. And it seems that this is the Ice Age, and glaciation retreat was having catastrophic issues on the population of Neanderthal that would collapse, recover. And late Neanderthals show really low genetic diversity. And it seems as if they were breeding themselves out of existence. I don't know if that's a fair way to say it, but when we came through, it seems to coincide with the last era of a struggling population. And it may be that we were slightly more competitive in the environment, and that was what led to their final extinction. With Denisova, it's not clear. The Denisova were there in Asia for hundreds of thousands of years. We know from the genetic data that they were quite a widespread species, and we don't have enough information at the moment. The way I read the literature at the moment, I think there may be as much luck, timing, and demography as anything else that explains sapiens' survival today. There is an argument in favor of some greater adaptability in terms of our physical nature and in terms of our cognitive abilities. But I think it's not reasonable to say that we just came and were better than the other hominins, and that's why they're not here.
Fascinating. And the chapter is wonderful. You paint this beautiful picture of all of these different species, and it's a great introduction to anyone who wants to know about this. So thank you for writing it, and thank you for this interview.
It's a pleasure.
Cheers.